Okay, we're going to talk about double angles now. Double angles have a lot of different formulas that could be helpful to us. Cosine in particular has 3 different ones. Okay, they have cosine squared u minus sine squared u, which is the one that I use the most when solving right triangles. And then we've got 2 cosine squared u minus 1 and 1 minus 2 sine squared u. These are all equivalent. When we're verifying or when we're solving, we normally have to choose the one that's going to help us the most in the equation that is given to us. Sine only has one, 2 sine u, cosine u, and then tangent also only has one. Tan 2u equals 2 tan u over 1 minus tan squared u. So the first thing you're going to have to be able to do with this is to expand and condense like we did before. So looking at the equation they gave us, it says cosine 2 cosine squared u minus 1. So if I look up here, 2 cosine squared u minus 1 is cosine, so I'm going backwards. So this would be cosine of 2 times 40, which would be cosine of 80, which we cannot simplify. That's as far as it goes because it's not on the unit circle. The next one, we've got 2 sine of 50, cosine of 50. That looks just like the one for sine, so that would be sine of 2 times 50, or sine of 100. This is also not on the unit circle, so that's how we're going to leave it. 1 minus 2 sine squared of 10 looks like our cosine one. So then we're going to switch that back to cosine. So we're going to have cosine of 2 times 10, or cosine of 20, not on the unit circle, so we can stop. And then we've got cosine squared of 30 minus sine squared of 30, which again is another one of the cosines. So this is going to be cosine of 2 times 30, or cosine of 60, which is indeed on the unit circle. And cosine of 60 is going to be 1/2. Now we're on to the right triangle trig part. Okay, so of course I'm going to start by drawing my triangle and labeling my sine as 3/5. So my bottom here would be 4. Again, if you don't know that, Pythagorean theorem, okay, is how you get it. And then we're going to follow one of the equations that we choose. I tend to choose the first one. So it's going to be cosine squared alpha minus sine squared alpha. So I'm going to take the cosine of this triangle, which is 4/5, and I'm going to square it. And I'm going to subtract sine squared, which is 3/5 squared. Remember, when squaring fractions, you square the top and the bottom. So that's going to be 16 minus 9 in the top and 25 on the bottom. And 16 minus 9 gives us 7/25. You could have used any of the 3 equations, but like I said, I think that one is the simplest when we're doing right triangle trig. Now let's look at sine. It's the same triangle, so I'm just redrawing it here for us. Okay, sine is 2 sine of alpha cosine of alpha. So we're going to have 2 times the sine of the triangle, which is 3/5. Please do not write sine of 3/5. You've already taken the sine of the alpha triangle when you are writing 3/5. That is the sine. And then we're going to multiply by the cosine, which is 4/5. And remember, when we multiply fractions, we just multiply straight across. That's technically a 2/1. So we've got 2 times 3, which is 6, times 4 is 24, and 5 times 5 in the bottom, which is 25. Tangent is going to be our last one. Okay, so tangent says 2 tan alpha over 1 minus tan squared alpha. So this is going to be 2 times 3/4 over 1 minus 3/4 squared. So in the top, I'm going to get 6/4. And in the bottom, I'm going to get 1 minus 9/16. Or 6/4 over 16 minus, or 16 over 16 minus 9 over 16. All I did was make my bases the same on the bottom there. So I get 6/4 over 7/16, and now I have a fraction divided by a fraction. So we keep the first and flip the second. So we get 24 over 7 as our final answer there. Okay, 24 over. Okay, then we're going to talk about some verifying. Okay, so we're trying to make one side look like the other. I'm noticing that I have a sine 2 theta on the left, so I'm going to change that to 2 sine theta cosine theta. And then over on my right side, I've got a cotangent, which is cosine theta over sine theta. And then I'm multiplying that by sine squared theta over 1. I got a sine in the bottom and a sine in the top, which is going to cancel. So we get 2 cosine theta. We're still left with 1 sine since it was squared in the top. So 2 cosine theta sine theta equaling 2 sine theta cosine theta, which are exactly the same thing because multiplication is commutative. So we can change the order and it's fine. All right, we've got sine squared theta equals 1/2 times 1 minus cosine squared theta. So I'm going to keep the 1/2 on the outside there. And I'm going to change my cosine to theta. I'm noticing that I need a sine squared. So if you look up here where I had highlighted, right, we do have a sine with the cosine there. Now we don't want to choose cosine squared minus sine squared because that's going to give us a cosine in the equation and we don't want a cosine, we just want the sine. So we're going to do 1 minus 2 sine squared theta. I put that in parentheses to make sure I distributed my negative to both terms. So I get 1/2 of 1 minus 1 plus 2 sine squared theta. Okay, so that's going to be, the ones will cancel, and we have 1/2 times 2, which is just a value of 1. So we get sine squared theta. Okay, for our next one, we've got cosecant 2 theta. Now, cosecant is not one of the formulas we know, but we do know that cosecant is 1 over sine, so 1 over sine 2 theta. And if we can change that to 2 sine theta cosine theta, okay, over here we know that cosecant is the reciprocal of sine, so it's like saying 1 over sine theta over 2 cosine theta. And that's just going to be 1 over 2 sine theta cosine theta equals 1 over 2 cosine theta sine theta, which again are the same thing because multiplication there is commutative. So we have proven that one to be true. Okay, the last one here, we've got cosecant. Again, we just showed in the last one that that's going to become 1 over 2 sine theta alpha cosine alpha. Oops. Okay, and we're going to change cotangent to cosine to alpha over sine to alpha. Okay. I'm looking to my right, I'm seeing I have a tangent, and I know that tangent needs to have a sine on top. So I'm going to change my cosine 2 theta to the one with sine again. So I'm going to have 1 minus parentheses 1 minus 2 sine squared theta in the top okay, over here we've got sine of 2 alpha on the bottom, which again is going to give us the same bottom as we had over there on the last fraction. So 1 minus 1 will give us 0, and negative times negative gives us a positive 2 sine squared in the top. And in the bottom we got 2 sine, oh this should be an alpha, sorry, alpha cosine alpha. We got a sine in the bottom that's going to cancel into 2. And then we get left with 1 sine in the top. So we get sine alpha cosine alpha, which equals tan alpha. And that concludes the video on double angles and solving the triangles. I created another separate one for solving, so go ahead and check that one out too.